The angle between two vectors.
Cosine theta equals u dot v over the two magnitudes.
How do you do the angle between two planes? It's almost the exact same. The difference is this. The angle between two vectors the angle between two planes what's the only difference between those two formulas? Yeah. So there's an absolute value on the one for planes, whereas the one for vectors, you could have a negative up top. But for planes, you can't. Right? Probably the most important formula you ever learned for vectors is right there. That angle between the two for all sorts of different things. All right, so we did that. We talked about finding intersections. We talked about projections. We talked about distance from points to lines, points to planes. Oh, and then 11.6 happened. What are we doing in 11.6?
All those shapes.
The 3D shapes, the ellipsoids, the paraboloids, cylinders. What's a cylinder?
Any shape where it's just like itself stacked to height in the.
Is this a cylinder?
I guess it is.
Because it is a line stacked with a line, stacked with a line, stacked with a, this is a linear cylinder. What's this? Parabolic cylinder, because it's a parabola to parabola. So our idea of a cylinder does not have to be this anymore, correct? There are all sorts of different cylinders that exist out there. So we had that whole conversation, and we had all of the 3D shape stuff, which you have a handout to help with, correct? Help visualize. Make sure if you're ever sketching, our pictures are gonna suck because we're not artists, right? So what's the most important about the pictures? The labels. Make sure you're labeling which axes are which, what direction is positive, and like when it hits one of the axes, mark, like that's at the number 2 or that's at the number 3. The labels are the most important thing. And maybe even telling me what shape it is. So you can be like, I'm attempting to draw an ellipsoid, and then do it. So even if it doesn't look anything like an ellipsoid, I know you know what it is, and I know that you got the right spots, right? So the labels are the most important things if you're graphing. And then what we do in 11.7, those were the coordinate systems. Going between rectangular and polar, which is 2-dimensional, and then going between rectangular, cylindrical, and spherical in 3 dimensions, being able to convert back and forth. In the long run, we're gonna need to work in all 3 of those. So by the time we hit chapter 14, chapter 15, we're gonna have to go in between those fluidly. There's 4 questions over everything we just talked about. So that's where we're at. Exam tomorrow, 8 questions long. 4 questions off of chapter 12, 4 questions off of chapter 11. An hour to do it. I'll give you 5 extra minutes, so you have a full hour to do it. All the quizzes and answer keys are out there and graded. So you can see what your grade is, you can check those answer keys for studying purposes. Is there anything in particular you guys want to talk about or need to discuss? I mean,
I think I know how to do this, but I'm always struggling when finding a point of intersection of just 2 lines in 3-dimensional space.
it's hard. Because what are the chances? So let me show you this. Do these lines intersect?
To me, it looks like they do.
I know, but do they?
No.
No. In three-dimensional space, what is the chance that two lines actually hit each other?
Close to zero.
Yeah, it very rarely happens, but can it happen?
Yeah.
Yeah. So actually finding intersection of two lines is a quite difficult process. We can just make one up. Give me an equation of a line, which means it has to be parametric, correct? So just make up some numbers here. Give me a number, 3t plus,
5
and then,
t minus 6
and then,
8t plus 2.
are we good that that's the equation of the first black line? All right, now we got a second line. So give me different numbers. Ooh, I should probably make sure they actually do cross, shouldn't I? All right, so let me think. I'm gonna do this, try to do this in my head. Two T plus 4 negative 2t minus 1 and 6t minus 2. All right. I want to know if those intersect, and if so, where? Well, normally when you think of things intersecting, how do I find out where they intersect? If I were to write two random equations up here, y equals x squared and y equals x, how would I find out where they crossed? We set them equal to each other, that's what we do. So we literally do the same thing. If they're gonna be going through the exact same location, so when I think of this, this is a parametric equation for this sidewalk, right? And you could be walking on that sidewalk at one speed, somebody could be on it at a different, because aren't there a whole bunch of different parametric equations for this line? And then I have this one that's doing the same thing, right? So they're just sidewalks. Isn't there an XYZ location where the sidewalks touch? Right? But do two people need to be walking and going through that intersection at the same time? No. So what happens is, these are crossing, but they're crossing at different times. So the first, where are they crossing? What I literally do is I set the x's equal to each other, because the x's have to be the same x. And the y's have to be the same y's. And the z's need to be the same z's. Make sense? The problem is this black T the same as this blue T? Because what's the T stand for? So this is the time the black one hits it. This is the time the blue one hits it, and they don't have to be the same, which means I have to make those symbols different. So I can either subscript T1s for these and T2s for those, or a common thing to do is I want to change that to a different letter. What letter did I just change that to?
How?
Tau, Greek letter T, little t. Just so I know they're different, correct? Isn't this a system of equations? So I'm going to rearrange them so that all the variables are on one side and the numbers are on the other. So I'm going to rewrite this as 3t minus 2 tau is equal to -1. T plus 2 tau is equal to 5, and then 8t minus 6 tau is equal to -4. Everyone agree that that's the exact same set of equations? Or at least make sure I did it correctly. How do you solve this? How do you solve a system of equations? Maybe I should ask it differently. What is the fastest way to solve a system of 3 equations?
Adding.
That actually is one of the longer ways, which is the adding. Adding and eliminating are the same method. Maybe I should back up. How many methods are there for solving this? Substitution is one of them. That's a go-to, but it's longer because there's 3. Now, if there's only 2 equations, both of the ones you've described would go fast. But because there's 3, it becomes longer and more involved. There's a faster way to do it.
Are you looking for like reduce row actually?
That would be it. What method is that? That's the button in the calculator.
Yeah.
All right, so we're gonna back up. There are 7. There are 7 ways to solve this. You've given me 3 of them. You gave me elimination, substitution, which is good, and then you gave me this RREF, which is half of a way. You haven't given me the full name of that yet. There are 4 matrix ways to do it. 3 non-matrix ways. What's the other non-matrix way? The third non-matrix way is to literally graph them and use your graph to tell me where this is. 2 dimensions, that's not too bad. Think about your graphs in 3D. What are the chances you can draw this perfectly to know where these intersect? Not very good. So graphically, substitution and elimination, those are your 3 non-matrix ways. What are the 4 matrix ways? Gaussian elimination with back substitution. And that's the REF button in your calculator. Then there's the Gauss-Jordan elimination, because basically Jordan came along and made it better. And that's the RREF button in your calculator, which stands for what, by the way?
Reduce rows.
Yeah. There was a way to do it with determinants. Anyone know what that one's called? Kramer's rule. By the way, Gaussian, Gauss-Jordan, Kramer's. How do we name things in math? It's whoever discovered it, or exactly what it is, like elimination, substitution. Isn't that the literal process of it? And then the last one is, you can use matrix algebra and use the inverse matrix. RREF is the fastest. So, you should be pulling out your calculators. What is the matrix that I'm going to use?
1, 2, 5, 8, 6.
And then you're going to hit the RREF button. And I'm hopeful that you will get a matrix that looks like this. And there should be a couple numbers here that I don't know what they are. Actually, I do know what they are. I'm hopeful that you end up with something that looks like this. If I did the numbers correctly, this is what you should end up with. This RREF is probably one of the most useful calculator things you should know. If you do not know how to type RREF or to solve a system with reduced row echelon, you need to make sure you do. Because this will pop up in every math course about at least once. Not a lot, but at least once in every math course where you have to solve a system like this. So knowing how to enter it in as a matrix and knowing where the RREF button is Anybody get done with it yet? Is this what you get? Good. Now, how do I interpret this? So if you're thinking about this, what did the first column represent? What did the second column represent? And then the third column was the constant. So now if I come over here, if I literally read this, this says t equals 1. Yeah, 0 equals 0. Is that a true statement? Yeah. If I would have gotten a 1 here, that would have said 0 equals 1, and then there would have been no solution, and then they wouldn't have crossed. But here they do. They cross here. Those are the time values when it happened. T is the time value for what? The black one. Tau was the time value for the second one. Plug 1 into the blacks. Eight, -5, and so this is the point, 8, -5, 10. Just to make sure, plug 2 into the blue ones. They both sets of sidewalks go through this location. But the people walking on the black sidewalk get there at time 1, and the people on the blue sidewalk get there at time 2. So the people on the black have gone through it by the time the people on the blue go through it. Kind of an interesting problem, right? It's really about understanding how parametrics work. It's not just literally the location, but it's also the location and a time value all have to make it happen. So now I'm gonna ask you this question. How often do two lines intersect in 3D space? How many intersect at the same time? It'd be even less. Because these would be considered intersecting, but they don't intersect at the same time. So intersecting to begin with, your odds are really low. Intersecting at the same time, your odds are even lower than that of it actually happening. Could it happen? It could, but it's very rare. But that's how you do it. You have to set them equal to each other with different time values. I like that problem. So understanding how parametrics work, understanding how vectors work, all of the possible things we can do with those. That's what I tested. Yeah, Jacob. That'd be okay too. It just means that that line, like let's say the Z was 2. So, let me see if I can. Right now, this line comes out into the room, right? Like this. If it was like this, then that line would be flat because it would always have a Z value of. So the X and Y's would change, so that sidewalk would literally be flat at a height of 2 the whole time. But it's still 3D, and I'd still have to worry about the other line intersecting. So it is possible to have that as a constant. This goes into the room like this. This goes into the room like this.
And then should we assume that the first line, when t equals 0?
No.
It's doing the same.
Well, it depends on what you're trying to do. If you're trying to find an intersection, no, you can't assume anything. If you let t equal 0, then you're assuming a time, but you don't know if that's the time where they actually meet or not. Now, if you're just trying to draw it, sure, you can put a t equals 0 and a t equals 1, and that will give you 2 points, and you could then draw the line between those 2 points. I'm not exactly sure what your question is.
Is of the intersection. Should we assume that it's zero
Mm-hmm.
in this case?
Because you would have no idea, it wasn't 0. If we would have made that assumption, it wouldn't have worked. Because it actually happened at 1 and at 2, it didn't happen at 0. So you can't assume it's gonna be 0. We have to do generic time values, because I don't know what time it's gonna happen. And then solve for the times. Once I know the times, then I can plug them in to find the actual location where it happened. And I gotta be careful because I can't plug this t equals 1 into the blues, because that was the time value for the blacks, and the 2 was the time value for the blue ones. So you gotta make sure you're plugging them into the right ones also. What else?
I was having a little trouble with projectile motion, in particular, number 37 and 12.3.
Is that the A bail?
Yeah.
I believe that the answer key to that is out on Talent, because it's a more complicated one, and so I posted that out there. I will tell you, there's no projectile motion on the test.
Oh, okay.
I'm not putting work, I'm not putting torque, I'm not putting the projectile, I'm not putting the application stuff on the test. That makes sense.
No torsion either.
Yeah, no torque.
Oh,
Yeah, no torque, no, projectile motion, no work. Yeah,
How do you conceptualize lines in like parametric form?
very careful. No, I literally think of them as, okay, I know that it's doing this. So now I gotta line this right. So I need a starting point. So this would be where I put in 0 to visualize, right? So I put in 0, it starts at 5, -6, and 2. So that's 5 out here, -6 over here, and 2. So I'm starting here. And then the slopes, I get to go 3 in that direction, while I'm going 1 in that direction, and 8 in that direction. That's my line. That's how I conceptualize it.
And
Because it's giving me the point and the direction vector. So once I have my point, and I know the direction vector, that's what it looks like.
should I put t in there at all, or t just shows you where everything's at?
T shows, so this is t equals,
0,
this is t equals,
1,
this is t equals.
2.
Now, technically, if I was being really good about this, when t equals 1, that is at the point 8, -5, 10. So that's like really far.
Yeah.
Right, that's where that dot is. So if I was doing tick marks, I'd have, 3 this way, 1 this way, and 8 up. Would be from here to here. So that's how I conceptualize them or visualize them. Yep.
Wanna go back to my question?
Yes.
So, if, the blue Z was like 6.
Yep.
And the black one was, 8, D plus 6, should we in this case like, test for T equals 6?
So t equals 6 for the blue.
So Z, yeah, so,
Z equals 6,
yeah, that's the big,
just for the blue?
yeah.
All right, so then what would happen is, conceptually, that wouldn't be there. This wouldn't be there. This wouldn't be there, right? Which would make this a 0. And then we put it into RREF and see what happens. I'm betting that those don't cross. But maybe somebody can do that for me? Can somebody type this in? we see the adjustments that have to be made, right? The process is the same, I just have to adjust it.
The last column, is just your zero.
Which then implies they do not cross. So this was a line that ended up being under the floor at z equals -2, but it's horizontal, right? Whereas the black one is still over here where we just described it, pointing up and out. Well, will those ever touch each other? I mean, this goes up like this, so it's not gonna hit. The only place it could possibly hit is when this hit the floor of, or at z equals -2. But they're well apart from each other at z equals -2. Which is why they don't intersect. And in fact, what are the chances that they do intersect? Rare. So most of the time, this is what's gonna happen to you. Most of the time. But every once in a while, they do cross, and they'll cross at two different time values. What else do we need to talk about? So you guys are ready? You can take it right now?
Can you do a problem from 12.4 and 12.5?
You bet. Let's go grab one. Whichever ones you'd like to do. So we're talking curvature or arc length or T-hat in hat. Right, that's what we did in those sections. Again, reminder, you get a 3x5 card. So some of these, like formulas for curvature, formulas for arc length, formulas for whatever it is you want a formula for, you might want to make sure they're jotted down on that 3x5 card for tomorrow. If you need 3x5 cards, I have some up here. Find one more one.
Just about.
Distance from a point to a plane, distance from a point to a line, those would be formulas, good formulas to be on there. Angle between planes, angle between vectors, those would be good formulas to have on there. Midpoint distance formula, equation of sphere, those might be handy. Just trying to think off the top of my head as we go through what kinds of things you wanna have there, just in case you don't fully remember them. Maybe even, how do you calculate a t-hat? Which is what, r prime over, or v over magnitude of v, depending on what you like to write it. Same with the n hat, making sure that it's t hat prime over magnitude of t hat prime. One of the most common mistakes is I see people use t instead of t prime when they're trying to do their n hat. Yeah, just making sure all those things line up the way you want them to line up. It's handy to have them written down to make sure you have all the details with you. And you are allowed to use both sides of the car, just so you know.
Can we do number 19?
Yep, that's what I'm saying.
Find the unit normal vector to the curve at the specified value of the parameter. RT is equal to 6 cosine t I hat plus 6 sine t j hat plus k hat. T equals 3 pi over 4.
3 pi over 4. So like that. And we gotta go all the way to n hat, is that what we wanted?
Yeah.
N hat, okay. What do I need? By the way, when in doubt, what's the first step you should always do?
I don't know.
Derivative. They all require a derivative, right? So when in doubt, at least put the derivative down, because that's gotta be the part of the problem somewhere. Agreed? That'll be at some points, no matter what happens. So what is the derivative of this?
Minus 6 sine of t minus or 6.
And then a positive 6, and then a 0. Feel comfortable with the derivative? I also need then the magnitude of that, which would be square root of
Cosine of t squared.
36.
Oh, it's 36 sine of t squared, 36 cosine of t squared.
And actually, I'm just gonna be nitpicky. You said cosine of t squared, and that is not true. That is not cosine squared of t.
Oh, okay.
Those are different. Unless you say the quantity cosine of t squared.
That's what I'm hearing.
I agree. So this is one of my favorite things to do. I love writing what you say, not what you mean. Because I know what you meant. I know exactly what you meant. But that's not what you said. And we gotta make sure how we say it and what we mean line up, right? Because the words, they mean things. So I just wanna make sure we're all on the same page. We see the difference between these notations, right?
Yes.
Yeah. We just gotta make sure that we're conveying what we want. Now, up here, what do those have in common?
36.
So this is 36 times sine squared plus,
Cosine squared.
which hopefully you guys recognize that. So this is literally,
6.
so the magnitude is 6. This is a nice one,
Oh, thank you.
right? Things are canceling out nicely for us. So, what's t hat?
It would be minus sine of t, and then cosine of t.
Yeah. I'm gonna write the extra step, but you are correct.
Oh, okay, okay.
Yeah. So it's the r prime over the magnitude of r prime.
Yeah.
And then, of course, when you put that number in, all the 6's cancel. I guess technically I should be writing this as t hat of t, and that would give me negative sine, positive cosine, 0. Questions about t hat? That's all good? Okay. And then I need over out t hat prime, which is
Minus cosine of t and minus sine of t. And also 0.
everyone agree? And then I need the magnitude of t hat prime, which would be, yeah. So square root of cosine squared plus,
Excuse me, shouldn't it be negative cosine? Negative 6 cosine, please?
here,
Derivative of t hat, the derivative of t hat.
You divide by scale. Easy.
oh, I already divided by 6.
Oh, okay.
So t hat has no number, it only has ones on it, right? Because to get the t hat, it's the r prime over the magnitude, and then that 6 cancels.
Yeah,
And then I go do the derivative after that.
forgot that, sorry.
You could do it from here, but then you have to follow the extra 6 anyway, and then they cancel later. I'd rather cancel them earlier and not have to write all the extra, right? Yeah.
What does it mean that our our t hat prime is going to be the same as the normal vector?
Yeah, t hat prime is already a normal vector.
Oh,
Because we just proved that the magnitude of it is,
yeah.
which is the definition of it being a,
Okay.
now, t hat is already of length 1. Because
Yeah,
that's the definition of it, correct?
yeah, yes.
It just so happened in this particular problem, it won't always happen, but in this particular problem, the derivative of it also happens to be a unit vector as well.
Yeah.
Won't always happen, but it's kind of neat that it's happening right here.
Oh, yeah, but I was wondering, what is it, what is that, does it mean anything that
No.
happens, or is it just a?
Just a coincidence.
Oh, okay.
So n hat would then be the t hat prime divided by the magnitude, which was 1. So what do we end up with for t, or n hat?
The same as,
Is
t
t
hat prime.
So negative cosine t, negative sine t, 0. That's your n hat. So maybe to answer your question, what does that mean? Why is that special? It means that that already is the n hat. That the t hat prime is the n hat because it was already the unit vector.
Yeah, I mean, I was wondering if there's, I guess, geometrically in our derivative of our t hat is.
Other than we know that
direction.
all of those are perpendicular to each other, right? N hat and t hat are perpendicular.
Yeah,
Okay, I'm sorry, I boxed that, but that's not the correct answer. Because this gives me the normal vector anywhere I want it. It specifically asked for it. And if I was being really good, I should have called this n hat of t. So then I have to do n hat of 3 pi over 4, which would give me negative cosine of 3 pi over 4, which we should know, and the negative sine of 3 pi over 4, which we should know. And I'll switch colors so that you can actually see the end result. You probably can't see that light green very well. What is cosine of 3 pi over 4? So it makes it a positive rad 2 over 2. What's the sine of 3 pi over 4? Rad 2 over 2, so that's negative rad 2 over 2, and 0. That would be the answer to this particular question. Right, that's all I asked for was find the unit normal vector.
yes.
So hopefully when you're doing these things, sometimes they could get really messy, but other times this stuff actually reduces quite nicely.
Because it's a circle.
Well, this part is a circle, right? And then that could make it a helix if it had a variable in it or whatever. But yeah, if you have a sine and a cosine, that means in the x and y plane, I've got a circle going on. Does that mean that it will always reduce nice? Not always. What if I had an ellipse? Well, then these wouldn't factor out nice, there'd still be numbers on these, and then you'd still have sines and cosines, and then you'd have square roots on the bottom with sines and cosines that you had to then do a derivative of, right? So, no, it doesn't always come out, but on circles, yeah, there's a better chance that that will all come out nicely.
this be on the nicer end or on the nastier end?
Could be anything.
Okay.
No, I try not, because time becomes an issue on these tests, right? Because they're long, because the problems are long. So I try not to give the overcomplicated ones. I try to hit somewhere in the middle. I don't like easy questions though. Right, so I don't like to put just super simple on there. So I try to hit somewhere in the middle. Of course, some of that comes down to what happens if you don't reduce? What if you would have put this right here? Would you still end up with the correct answer? Yeah, but think about all the extra work you just created. So I can't save you from yourself, right? So there is a way that goes pretty smoothly, but if you don't choose that way, it might end up looking much more complicated than what I intended. But I intend them to be middle of the road problems. That's what I'm looking for when I do these. A lot of it comes down to, do you understand notation and the terminology? Because if you understand what it's asking, you know exactly what to do with it, and you're good to go. If you kind of know, and you get in there, and you start floundering, that's when things get complicated. I will offer this bit of advice. When you take a test in math, you should read question number 1. If you're 100% sure you know how to do it, go ahead and do it. If you're 95% sure you know how to do it, skip it. Go to the ones you're 100% sure of, get them done, get those points. Because one of the worst things in the world is for me to say, okay, it's time to hand in the test, you ran out of time, and you turn the page and you see a problem you know how to do. Because those are points you just missed out on. So you go do all the 100% ones, get those points, plus, then you'll be on a roll, you'll be feeling good about yourself because you got all these problems done. So when you go to the one that you were like 95% sure of, you'll go right through it without any problems. But if you start with it, you might have a little bit flustered and you might get in there and you might screw it up a little and then you get test anxiety happening and then it screws up the other ones. So do the ones that you're 100% sure you know how to do first. Then go back and do the ones you kind of know how to do. And then the problems that you have no idea how to do, save those till the end, and then just put down whatever you can think of to try and get some points. Anything else you guys want to talk about? Good luck studying. Be here on time tomorrow, so we will start right at 9:05 so that you get the full amount of time. You are going to want the full amount